So basically, what I'm going to talk to you about today is some new library from AndroidX that is used for initializing any kind of dependency that you actually do other way around or some different way. So I'll be saying a word initialize a lot. I hope that doesn't really bother you. How do you initialize stuff with AndroidX Startup? Well, first we need to compare some stuff that we actually use in everyday projects, more or less. Well, basically you have a couple of options here, and your first option is the most generic one and most basic one. You have your application class and you have your own create overridden, and you basically initialize everything here. And you do this mostly just because I do it too, just because you need the context here. So the first thing you comes to your mind is to use the application class because of the context, and you need to pass it on to some sort of a library or dependency, and you do it in the application class. This is okay, but the problem with this is that you're basically postponing your process launch up until the main activity or your launcher activity is shown and rendered on your screen. And this is like the last stop that you can do this before it's shown on the screen. So if you have a lot of these dependencies, this is really bothering and postponing the rendering of that activity. So what else can you do instead of that? Well, there's this approach that I first noticed on Firebase that I was always wondering how Firebase initializes its own libraries and SDKs. And basically, when I dig up, was they use a content provider, and I was really okay with that. There are several issues with content providers. One of them is that you need to, if you're implementing this on a library of your own, you need to basically make sure that they don't collide if you have multiple applications installed with the same dependency, the same content provider. That's not allowed. They will throw an exception. The second problem is that you actually have a lot of unused methods, and you're just basically making them no ops or dummy methods, and you're handling a lot of boilerplate code because you needed something from this content provider, which is exactly the same thing as you needed from the application class, and that's the context. So the content providers are actually run before the application class, and they do have access to application context. However, there is the third problem with with content providers, and they are slow. Not really as slow as individual content providers, but they're slow when they are coupled with a lot of other content providers. So that's the problem. If you have a lot more content providers than just one, then they will initialize in a sequence. Now, this is a very familiar picture taken from the documentation, but it's really self-explanatory. I'm just going to jump through it. Basically, you have the application startup, and you can imagine that as pointing a finger at the launcher icon. Now, what happens with content providers is they initialize in a sequence, serial, like in a serial sequence. So if you have some kind of a heavy-duty initialization in the library A, for instance, and using the content provider A for that, that's going to take time and stop the initialization for the B and C part. It's not really ideal, but you'll get through it, and you'll basically see the screen at the end of this process of the initialization. Now, what else can you do better? Well, this basically means that you would do best if you have only one content provider and initialize everything through it. So that's basically what AndroidX Startup did. It's a really small library, basically, and doesn't have that much code, and it's a completely different logic. So you have your app startup, so that's like the place where you put your finger on the launcher icon and you expect everything to go fast. So what happens now is you have this new class called initialization provider, which is basically a glorified content provider, and it all implements multiple other initializers in some sort of order dependencies that we're going to show later on. So basically now you have the best of two worlds. You only have one content provider, which will do minimum damage, so to say, and on your application startup time, and you basically have all of the initializers and all of your libraries initialized in parallel. And then after they're all done, you'll see your main activity activity or launcher activity actually rendered on the screen. So this for me seems like a best solution or best trade-off solution to actually use in libraries or in applications. So let's take a look at the setup first, which is basically really, really simple. Of course, you have to have a Google repository included in your project because the AndroidX Startup is provided by Google. It's really simple. If you use it in Groovy, you just add this dependency as an implementation. It's a startup dash runtime. It's a stable release of 1.00. So no alphas, no betas, no RCs. It's a really stable release. If you do it in Kotlin DSL, it's basically the same as in Groovy, just with more brackets and double quotations mandatory. Same dependency. So after the setup, what you have to do is basically take care of a little bit of implementation. I'm just showing this interface because the initializer itself is the cornerstone of everything here. And the initializer takes a generic type, which basically tells your initializer, your implementation of this interface, what you're going to return. Now, there are two methods only that you need to implement. The first one is the create one, and this is the one that actually provides the application context for you. So this is just passing on what the content provider did in the simplest content provider solution. The second one is basically the dependencies method. And this method is basically important because you can add other dependencies that we're going to show in the examples and other initializers that are going to run. And the order here is preserved. So if you have a list that is, if you have a list of initializers that is set as a dependency of this parent initializer that you're going to implement, then these initializers will run first, and then the parent will run first. Also, inside the dependencies list, the order is preserved. So as you implement them, as you put them in the order, they will initialize at that same order. So let's look at some of the examples. This is a typical example where you have some kind of a, I don't know, made up camera object. So basically you want to initialize the expensive camera object at before the startup of your launcher. And this is how you do it. You implement, you create, you pass on the context, you get a new instance of the camera, and you can also return a camera object out of it. It all depends how you implement that generic type of the interface initializer. In this example, the dependencies list is empty. It can just be like that. So we pass on an empty list. Another example is quite controversial here because you return a unit and you do some kind of a dependency initialization here, like some sort of DI. But in this case, the showcase here is to use a unit. So you can return a unit as an object in Kotlin. And then again, you can use the context provided and initialize whatever you need with that context and simply return a unit, or in this syntax, nothing. And in this initializer also doesn't have any dependencies, as you can see in the second method overridden. Now, this is a quite different initializer. Basically, this initializer returns the class of another initializer. This is quite convenient for doing some sort of work in libraries, and it's actually quite common to use this returning of a class as a type of initializer when you're implementing in startup runtimes in libraries. So basically, why would you do this? Basically, you get the context. As again, you can see there are no dependencies, but you actually return a class object. Well, the reason for this is that you can actually then manipulate further on with some sort of initialization processes inside your own initializer. And you can do that in the code eagerly. You can do this, I don't know, by stacking other initializers like that in some other libraries. The other example is if you want to use initializers in an application project. So the previous example that I've shown was an example from a library project. And this example is, for instance, in an application project. Again, I can return a unit, but I don't do anything on create. However, I do initialize other initializers in dependencies method, and in this exact order. So this basically means that my initializer, awesome app initializer, doesn't do any work, it doesn't need any context, but it serves as a parent. Now, the question I've been asked most often is what comes first, what will initialize first. So basically, if you look at this example in order, Timber initializer will initialize first, Android 3.10, color, update, basically all in order. And then after they're done, then the awesome app initializer will basically initialize and finish the process of initialization in your application. So this is a neat way to initialize all those examples or libraries that don't yet support anything of the initialization or startup runtime, and to make it in order that you actually need. Quite common usage for this will basically be initializing Crashlytics initializer and library through implementation until they support it out of the box. So how do you actually use this? Well, you can use this the declarative way, as I said, or the imperative way. Now, the declarative way is actually the preferred way. So what you need to do is actually just use a normal provider. As I said, the initialization provider is a glorified content provider, and you add your provider node into the manifest application node. And there are a couple of parts that you need to be aware of this provider node that are almost the same every time. And there are a little bit of data that you need to make custom to your own implementation. So what's not important is basically not the application node here. The provider node is basically always the same because all that gray area here needs to be the same. So you don't want to export your initialization provider for other apps. You need to set always a specific authority and in the attribute specific for this application ID. It's the same very reason for the content providers that can be multiplied on different apps. So they need to be dependent on your authority. And you need to use the same name, of course. And then you can decide with normal manifest merger rules if you're going to merge this node, replace it, remove it, or whatever. The most important part here is actually the metadata subnode, which basically has two things. It has two attributes. It has a name attribute, which is the fully qualified name of your own initializer, and it has a value, which is basically just AndroidX Startup every time. So this is basically the only thing you need to have. You have to have your own implementation of an initializer, and you have to put in the fully qualified name of that initializer. Now, the imperative way is a little bit more complex, but there are actually only two public methods you should care about, besides the instance initializer. So you can see in this jumble code from Google that basically have a singleton pattern here on the app initializer class, which is provided by the library too. And the second two methods are basically just initialize component and is eagerly initialized. Now, behind this is just a common implementation where you can initialize your own initializer, as you can see. And the second method is eagerly initialized, is basically just a checking if it's already initialized or not. I think it's, if I remember correctly, it's all backed up by a hash map in the source code. So the imperative way, as I said, has only two important methods, and this is their usage. So when you create an instance of the app initializer, you have to provide it a context and be aware of that. And when you initialize the component, what you set as a generic type in your initializer is actually going to be returned as an object here. So in this case, some sort of object called jet. The second method here that is important is basically this is eagerly initialized, which just returns true or false as a Boolean, telling you if your initializer has already been initialized or not. And that's basically it. Now, the takeaway from this is, well, you should actually try or strive to use the declarative way if possible. But in some cases, it might be prudent to use the imperative way, but you have to be really careful about it. because you're the one deciding when is something initialized or not, and you have to take care of it. So a little bit of extras about this. There are a couple of things you can do also with your initializers. If you notice that some sort of library has some sort of initialization and initializer implemented already, and you don't like it, you want to postpone it, basically you can use a standard normal manifest merging rules and just remove this node from it. This means in this individual exclusion that basically from all of your initialization providers, just this one will be removed and thus not initialized, and leaving you to use the imperative way to initialize it when you actually want it. Besides this, you can actually have a complete exclusion of initialization. So if you have some sort of application or library provided to you that you need to implement and you notice that it's initializing a lot or something that is not correct, or you want a different version, basically you can disable this whole thing and this whole flow just by adding the tool node remove to the complete provider tag to a node to stop the initialization. In the manifest merger process, this will completely be removed and not visible in the end in the manifest. So what else can you do? Well, I've been asked, can you do dependency injection in initializers? Well, yes, there are some ways you can actually use entry points with Hilt. Not quite clean, but works. You can perhaps use it with Dagger, but it's really quite complex, not that easy, and really messy to do. And in some cases, depending on your usage, quite impossible because of the fact that the graphs are built in compile time and this is run before runtimes. This is in runtime. So there are some discrepancies. If you can basically smuggle in some of the graph parts inside your initializer, that's great. You don't have to put in some other initializers there as dependencies or put some in boilerplate, but it's mostly not recommended. Using coin, in this case, can be forced to work with initializers. But then again, you have to be aware how coin works because it's not code generator, it's a service locator. So then again, you need to manipulate coin and some of its obscure API to actually make it work with initializers. So initializers are basically meant to be used without any dependency injection. And if you need some kind of dependencies, they provide their own dependencies method that you can actually use to provide the certain dependencies. It gets quite complex if you go like several levels deep in this dependencies tree using only initializers, and you need to keep track of it, but they're not really meant for that quite more usage, extensive usage as we are used to by using Dagger. If you have an extensive usage, actually Dagger or some sort of other dependency injection would be preferred way. So what is the key takeaway from all of this? Well, they are really fast and they are really performant to initialize any kind of dependencies that you have. You can use the declarative or you can use the imperative way. It's all up to you. You can use actually the imperative way to postpone some kind of initialization that is costly, and you know it's going to, no matter how you implement it, and you know it's going to postpone the launch process, and you don't need it at the beginning. You can do it later. So it's up to you. It's up to your discretion and responsibility. You can use individual or complete exclusion. It's all up to you. You can control it completely. As I spoke to some kind of authors of this library, they actually had like initial thoughts were that they developed this for libraries, but then they actually figured out they can use it for applications if used properly, if implemented properly. So keep in mind that this is mostly like meant to be used for libraries, but there are no, at least at all, no issues to use it as an application project. It actually works best if all dependencies use it. Now, what does that mean? That means if you have like one initializer and initialization provider, and you have 10 content providers, you didn't gain much. But if you have all of the initializers and just one initializer provider, basically you gained a lot. So that's the balance between it. So the more dependencies, the more libraries, the more third-party dependencies implement this, the faster your application or another library will actually be. If you can't wait for that, you can actually wrap other dependencies that are still not implement this into your own initializers. But of course, the downfall of that, you have to maintain them until that third-party dependencies are actually up to date and use this. So thank you. That would be pretty much all from me. I hope I didn't speed too much from this. I'll try to find the QA section here. So Marco asked me if there is a guarantee that all dependencies will be fully initialized before the first activity of the application is started. And the answer is yes. It's totally yes, because as I said, initialization provider is a content provider. So if you have some kind of dependency that is a long, heavy computational work, for example, and you wrap it in the initializer, what will happen is basically you will take a lot of time to initialize this, but it will initialize completely, and then the launch process will continue before you hit the application class, basically. So yeah, this is maybe an example where you would probably have to use, for your own benefit, if you can, the imperative way to postpone the initialization as much as you can, or do it somewhere other, somewhere in the background or some other place. Is it worth it? Andras asked me. Well, it is. Actually, I developed a couple of libraries, and a lot of boilerplate I had to do to initialize some sort of a dependency tree on the libraries was replaced by a simple initializer. And on the projects that use most of these libraries, startup time has improved. Nobody asked me, do I have any numbers, but I'm going to actually tell you. Yeah, that's the question. The measurements are quite hard to actually to take or to log, because you would have to use the benchmark tools and everything. However, the logic is sound, that I've from practice, from the real world examples we've seen, that if you have something that is slow and you only have one of slow, that's faster than 12 of slows, so to say, which are content providers, and also the initial basic bicycle run in the application class. So yeah, it's totally faster than any other approach so far. It's streamlined. It's basically something that Google and Firebase team has been using for years now, and some other, I don't know, prudent library makers were also doing this. But the way they implemented it before, using only content providers, was basically quite risky if not done properly, because of the collisions and other stuff. But yeah, this would be the way to go.